Hello, everyone, and welcome back to another episode of Function Autoimmune. I have a fantastic guest on the show with me today of Dr. Bill Andrews. I'm so excited for this episode, and I know you will too. Dr. Andrews is a PhD in molecular and population genetics, founder of Sierra Sciences, with a focus on longevity at the cellular level. Hi, Dr. Andrews. How are you?
Very good. I'm glad to be on your show. Uh,
Glad to have you here.
I, I I gotta say, I've been obsessed with the curing of aging ever since I was 10 years old. It was something that my father was very interested in, and when he realized that I was interested in science and medicine, he just came to me one day and said, "Bill, when you grow up, you should become a doctor and find a cure for aging. I don't know why nobody's done that yet."
Yeah.
And there's actually a documentary called The Immortalist, which I star in with Dr. Aubrey de Grey, where my father is actually interviewed, and he tells that story. Fortunately, my father passed away ten years ago now with from Alzheimer's. And so, but up until then, he and I were really teaming up, even going to anti-aging conferences together and stuff like that. But yeah, I just because of that seed that my father put in my head, I I just have been focused on learning everything I could about aging, like what aging is,
Yeah.
why we age, how we age, and more importantly, how not to age. And it's been those four subjects right there have been the obsession of my life. And I've learned a lot. One thing I've learned is everybody's wrong.
Yeah.
Okay. And it's like there's all these kind of theories and stuff like that. But it, what I've learned from all my education and taking all these classes and like everything from logic to statistical theory to evolution to, all these kind of things, I've learned that aging really doesn't need to be defined and explained by theories. There's I mean, it was inevitable. There's no way not to age, given physics and the natural laws of physics and things like that. It's like on the subject of like, well, first of all, what is aging? Aging's really just a decline and failure of multiple tissues and organs, um, and but it's all throughout the body. Aging can't be defined by just one organ or tissue in the body failing. It's got to be defined by all of them, and that's how you define aging. And even how do you measure aging? That's something that's really impossible too, because people have all these biomarkers of aging and stuff, but none of them individually mark aging. And when you reverse one of those biomarkers, you haven't reversed your aging. You've
Mm.
just reversed the biomarker.
Yeah.
And that includes the thing that I spend most of my time working on is telomere biology. That
Mm.
includes telomere length. Okay. Telomere length, just because somebody lengthens your telomeres, that doesn't mean you reversed your aging. You have
Sure.
to you have to pass all the other tests too. And I will often define the aging measurement of aging as passing the Betty White test. I will
I
show
love that.
pictures. I'll show pictures of Betty White when she's 25 and 85, and I'll say, okay, does anybody here not know which photo of Betty White was taken first? And
Yeah.
after everybody laughs, I say, okay, so isn't this the biomarker we're all interested in?
Mm.
It's like who cares what your DNA methylation patterns are, your IgG glycosylations, or your grip strength, even all these different measurements of aging, unless you've passed the Betty White test. And that means going back to looking, feeling, and behaving like you're 25 again.
Yeah.
And that's what, when you walk into your doctor's office, that's what you want. You're not asking, make my telomeres longer, make
Yeah.
my DNA methylation patterns different. You want to look, feel, and behave like you did when you were 25. And that it's not a quantitative marker. We can't look at Betty White's pictures and be able to figure out some measurement exactly as to what is different between her. We can take the wrinkles away, the fat away, the hair color away, and we'll still know which photo was taken first. There's so many different things involved. So but that's okay. So what aging is, how we measure it, those things. Why do we age?
Mm.
Okay.
Yeah.
Why have we never evolved a way not to age? I
Right.
mean, it's a terrible thing. Well, this is what I got from studying my PhD in population genetics is really not, it's about evolution, but not the what and when. It's the how and why. I mean, why did we evolve this thing, and how did we evolve this thing? And
Yeah.
I've it was a real eye opener in learning everything I did about evolution, and then be able to use that to formulate a plan, which I don't even want to call it theory because it's so obvious that it has to occur. But
Yeah.
it comes down to the simple fact that our environment has been changing for millions of years. Okay.
Sure.
Humans have only been around for 300,000 years, but even before then, if you believe in evolution, which I do, but doesn't mean everybody has to. But if before then we were going through changes where our prior species, let's say, or whatever, had to survive rapidly changing environments.
Sure.
And the way to do that, the best way to do that is to have a lot of diversity within the species.
Right.
Okay. So the more differences there are among the different members of the species, the more likely at least one or a few members of that species will survive whatever new environment comes along.
Yeah.
And so from an evolutionary perspective, it's always been evolution is not a force; it's a result. So if I make it sound like a force, believe me, I don't think of it that way. But it's it's the species more likely to survive were the ones that added diversity. And so all through evolution, everything from rates of mutations to rates of like making our chromosomes diploid to uh, all kinds of different things. But the number one biggest thing that increased diversity within our species was the introduction of sexual reproduction, because now we're shuffling our genes, which added tremendous diversity that didn't exist before.
Yeah.
And then almost instantly, as soon as that happened, it became clear, if you were thinking of evolution as a force, that the only way to improve diversity even more was to eliminate the longer lived. Okay. And by the way, I don't use old.
Yeah.
I don't use the word old because life's about living. So I say longer lived, but to eliminate the longer lived after they've uh, raised their young,
Mm.
okay, because now more diversity occurs in the species by allowing the offspring to interbreed than to let the parents rebreed.
Mm.
Okay, so the species that eliminated the longer lived were more likely to survive. Now, it was no trouble to evolve something to eliminate the longer lived,
Mm.
okay, because cancer, heart disease, all these kind of things all seem to be things that really affect the longer lived more than the younger lived,
Mm.
shorter lived. And so it was like this is why we've never evolved a way not to age.
Mm.
Okay. Because
Yeah.
all these things of decline of organs and tissues all accumulated together to increase the chances. Now I'm sounding like evolution's a force, but increase the chances that will eliminate the longer lived after they raise their young. So that's why we age. Okay.
Yeah.
And that doesn't need to be a theory. That's a fact. There's no way to prevent that. That's inevitable. Okay. So how we age is another thing that I've gotten really well understand really well. And that's it does begin with wear and tear. Okay. And just like an old truck sitting in a field that's exposed to the sun, the wind, the rain, and things like that, it suffers a lot of wear and tear.
Mm.
We are different from an old truck sitting in a field because we have cells
Mm.
that can divide to replace those damaged cells.
Right.
So even when I was doing anti-aging clubs in high school and college, we were asking the question, why do we age if we have the ability to replace our damaged cells?
Yeah.
And so in 1961, it was discovered by Dr. Leonard Hayflick, or he published it in 1961. I think he learned it in the late 1950s. He published that human cells can only divide a limited number of times.
Mm.
And so he found that when you take cells from a newborn baby and grow them in a petri dish, they can divide about 50 times. When you take cells from a middle-aged person, they can divide about 25 times. And when you take cells from a 90-year-old person, they can divide about 10 times.
Mm.
Well, what the hell? Excuse my language. What's
Okay.
going on here?
Yeah.
Okay. It's like, how could why is a human cell different from a bacteria cell in that sense, or
Hmm.
even a yeast or fungi that they can divide and divide and divide indefinitely? And
Right.
so we started thinking there had to be something like ride tickets at an amusement park inside of our cells. And every time a human cell divided, um, it would lose a ticket. And then after it lost its last ticket, it couldn't divide anymore. Just like you can't go on any more rides anymore after you've used up all your ride tickets.
Yeah.
Well, that was frustrating because I started after getting my PhD. I started interviewing labs all over the world working on aging to see if I could go work with them. I they every place I applied offered me a position, uh, but every I would explain this that there had to be something like ride tickets at an amusement park, and nobody seemed to understand that. So I went into biotech and instead and worked on cancer research, heart disease research, and inflammation and things like that. But I then um, one day my father and I went to an anti-aging conference, and we heard this guy, Dr. Calvin Harley, talk about the fact that telomeres shorten every time a cell divides. And so telomeres are found at the very tips of our chromosomes. They're actually made up of DNA, the same thing that the rest of our chromosomes are made of. And they're like the caps on your shoelaces or the aglets on your shoelaces.
Sure.
And every time a cell divides, they get shorter and shorter. And when they get down to a certain length, the cell can no longer function.
Mhm.
And so I instantly thought, "Oh my god, here's the ride tickets." Okay, and so I went up to this Calvin Harley and I said, "Has anybody figured out how to add more ride tickets back?" Because from a scientific method, that would be the way to prove that this had something to do with aging,
Mhm.
was if you added to, DNA back or ride tickets back, would that extend the lifespan of the cells? And he said, "No, we'd been working on it for years. We've been working with collaborators all over the world. Nobody's been able to figure it out." I just boldly said, uh, "Let me come and work with you, and I will have it figured out in 3 months." And I'd already had a pretty illustrious career in biotech. I'm, one of the inventors of human growth hormone and tissue plasminogen activator, erythropoietin, beta seron, like at least 10 times that many things.
Yeah.
But so he offered me the job on the spot. He thought this was a great opportunity. And so I went, he put three-quarters of the Geron Corporation reporting to me. And 3 months and 17 days later, we discovered this enzyme called telomerase
Okay.
that actually adds more ride tickets back. And we figured this out because we realized that if every time a human cell divided, the telomeres got shorter,
Mhm.
our children will be born with shorter telomeres than we have because our primordial germ cells, the cells that are responsible for making the sperm and the eggs, those require cell division.
Yeah.
And if telomeres are shortening there, our children will be born older or with shorter telomeres. Their children were born with even shorter telomeres, and we would have been extinct as a species. So
Yeah.
something was going on in our reproductive cells that prevented this telomere shortening. And we discovered that it was this enzyme called telomerase. And so that's pretty much how we age, okay, is because the wear and tear first causes aging, but we can't always repair it because of the telomere shortening.
Wow.
And like a good example is drinking alcohol. Okay,
Hmm.
if you drink alcohol, you kill liver cells.
Right.
That's okay when you're young because other cells can divide to replace those killed cells while you still have long telomeres.
Yeah.
But when the telomeres get shortened, now you're accelerating the shortening faster because you're killing cells faster. When you're 45, you suddenly can't divide, the cells can't divide anymore to replace them. So you get an accumulation of dead cells, and that's what liver cirrhosis is, and that's what kills you.
Yeah.
And so, but now, so we've got this whole idea put together now. So then I started Sierra Sciences, my company, to focus on trying to find ways of producing telomerase in all of our cells, not just our reproductive cells.
Yeah.
Because if our reproductive cells, or primarily our germ cells,
Mhm.
contained telomerase, the enzyme telomerase, that means all of our cells had to have the gene for telomerase.
Sure.
And we discovered that the genes just turned off
Hmm.
Every gene in your body, the ones that give your eye color, hair color, everything, they have dimmer switches next to them called promoters.
Hmm.
Okay. And so in the case of all of our cells, besides our reproductive cells, that dimmer switch is turned off by a protein called a repressor protein.
Okay.
And the reason is exactly what I explained before. It was evolutionary advantage to the success of our species to shut that gene off.
Yeah.
We would eliminate the longer lived. Okay, so we're smarter than evolution now. So I've been working on trying to find ways of dislodging that repressor, finding especially a nutraceutical, a plant extract,
Hmm.
have some kind of like molecule in it that would get inside the cells, bind to that repressor, dislodge it, and turn the gene on.
Yeah.
And so that's what we do. We have $1 million robots here, right on the other side of the wall behind me, is like 10,500 square feet of lab space. The only business part of the company is this room I'm sitting in. We're completely lab.
Yeah.
Okay, so we are testing. We can test up to 4,000 different plant extracts a day with our robotic systems, but it also requires like a bunch of employees too, because the robots can't do everything. We have to first. There's a lot of other work to do, but the robots can handle 4,000 plant extracts a day, but it's like impossible for the humans to keep up with that. So it can never do 4,000. So the
Yeah.
robots are definitely not the rate limiting step here. But we are testing as many as we can, and we have tested over close to 20,000 different plant, like fractions of plant extracts. Okay, because we don't do whole plant extracts. Well, we do whole plant extracts, but they never work because they got so many molecules in them
Mm.
that there's going to be things that might turn on that dimmer switch, and then other things that might turn off that dimmer switch. So
Yeah.
we have to fractionate the molecules into by size or charge or solubility and all kinds of things. And so typically we'll test like 20 to 40 different fractions of a plant extract each time. And sometimes we find a fraction of the plant extract that works to actually turn on this uh, gene for telomerase inside the cells in the petri dish. And so we've tested close to 20,000. We have found about 30 to 40 different plant extracts that do turn on this telomerase gene, but not enough to actually uh, be the same amount that's occurring in our reproductive cells. Okay,
Mm.
so telomere lengthening and shortening is like a tug of war. If I can show my hands here, that the so in the reproductive cells, a reproductive cell divides, telomere shorten, but then telomerase relengthens. And it shortens and relengthens every time a cell divides. In all the other cells of our body, we only have shortening. So we just keep getting shorter and shorter every time a cell divides. What we are doing now with the nutraceuticals is we are adding people to this other side of the tug of war, not really people, but
Yeah.
telomerase, but we we are not winning the tug of war, but we are slowing it down so far.
Yeah.
My goal is to win this tug of war, but we're not there yet. But I can tell you, there's nothing else on the planet that really does slow down the aging process, except for these nutraceuticals that actually induce uh, a little bit of telomerase to decrease the rate of this shortening. And
Wow.
so we've been working on this, and we typically every time we find something, since we're just a research company, we've been just putting them on the shelf, and because we want to find something that wins this tug of war. And
Hmm.
we've tested close to 20,000, but there's 3 million different plant extracts to test. So we got a long way to go yet. And I'm very optimistic that we're going to find things. And, and I think within 1 to 3 years, we'll find something that could win that tug of war. But we got a call one day from Touchstone Essentials uh, that said that they wanted to license uh, some of our discoveries and stuff like that and turn it into a product, even though it doesn't reverse aging. They said slowing down aging is a really good thing that's going to help people be happier and healthier, and that's what we're interested in. And I explained that we had talked to other companies, and they didn't. And actually, some of the companies did try marketing some of our nutraceuticals, but the profit margin was never good enough for them. Okay,
Hmm.
and so they wouldn't continue the product. But Eddie Stone, who's the head of Touchstone Essentials, says, I don't care about profit margins. I just want people to be happier and healthier. And this is something that's really important. So we licensed our top 5 uh, fractions of plant extracts to Touchstone Essentials, and they combined them into a product called Telovito. I'm not a marketer, but I am going to show this only because I think
Oh,
this is the best thing that anybody can do. Let me get closer to this. Get my camera. This
there
is
we
the
got
best thing
it.
that anybody can take to slow down the rate of aging. Now, people have been taking this now for months. It got launched just, I think, about 3 months ago. And there's already some people claiming that they're seeing age reversal. Okay, well, I don't understand exactly why that is.
Yeah,
Okay. Uh, and I would say, first of all, there's some people just having placebo effects or something like that, but there's just way
sure.
too many of these things. And I've studied some of these cases. So I've decided, well, these are plant extracts or fractions of plant extracts, and they are typically plants that already have a history of providing health benefits to people. And so and we don't have pure molecules from each plant. We just have a mixture of them. So there's probably other things in there too that are providing some benefits to people besides uh, inducing telomerase.
Sure.
Now, that's one possible explanation. But another one, which is actually really starting to look really great, is that there's several publications now, and we verified this here at Sierra Sciences, that when telomeres actually get really short, critically short, they become easier to lengthen. So it
Oh,
might be, even though we're not winning that tug of war,
mhm.
when we get short, the people pulling to shorten are falling off a cliff. And so there's fewer and fewer people. And then you reach a point where all of a sudden you start re-lengthening.
Mhm.
Okay, that might be the explanation. We have to do some more research to verify this, but that
Yeah.
might be the explanation as to why some of these people that have some problems that need to be fixed, therefore they have probably critically short telomeres in some of their tissues, they're probably seeing those critically short telomeres being lengthened.
Mhm.
That's just right now a guess. I don't want to say anything, but I think that's a really good guess, and I'm really anxious to start doing some studies to find out if that's true. Um, but but we are they are seeing a lot of things. And another really good explanation as to why the short telomeres, because we don't want to talk about people falling off a cliff. That's not going to happen inside of a cell. But
Yeah.
something that could happen inside of a cell is that telomeres are often displayed or shown in pictures and stuff like that as a linear thing, a linear string of DNA beads, bases. But the telomere might actually be folded up like a ball of yarn, and
Mm.
the tip might be buried in the middle of that ball of yarn. So
Yeah.
when the telomeres are long, that ball of yarn is big, and
Mhm.
telomerase is coming along, and it can't get to the tip of that telomere to lengthen it. So so it doesn't lengthen it. But when the telomere gets really short, that ball of yarn is really small, and so it becomes more accessible to telomerase to get in there and lengthen it. And that might be why the shortest telomeres are lengthening. And I think that's the best guess right now as to what's going on. But there's I'm actually seeing a lot of things happening that I can't really explain, but I from a scientist's perspective, I can say Telovito contains ingredients that will decrease the rate of telomere shortening, therefore decrease the rate of aging,
Yeah.
but it's looking like it's even doing better than that. So, and we'll have more data later. Okay, so what have I not talked about? Okay, so the how not to age is to continue this research. Now, I don't want to say that telomeres are the only thing that's involved in the aging process. I mean,
Sure.
I'm I'm trying to cure my own aging. I want to be healthy, live longer. When I want to be around, my big fear of aging is the fear of missing out on great things in the future. I want to be around when we make first contact with aliens from outer space. I actually have a great picture of me and slides where I show me and in the picture of Star Trek First Contact, where humans actually shake hands with Vulcans for the first time. I have a thing where I actually suddenly appear with a three-way handshake in that because that's what I really want to do. And that's April 5th, 2063, and when that's supposed to happen. I probably won't be around by then. And so to be around by then, I've got to come up with a cure in aging. But
Yeah.
in the meantime, while we're trying to find something that actually lengthens telomeres to win that tug of war, I'm doing everything I can. I'm taking stuff to help my mitochondria. I'm taking NAD, urolithin A. I'm taking resveratrol. I'm taking just everything. I take a lot of supplements. Plus, I'm exercising. I have a whole not theory. I've done enough works on like ultra marathons. I've taken blood from runners before, during, after, measured certain things. Um, like inflammatory markers like CRP, electrolytes, things like that. And I'm convinced that the best way to decrease inflammation and oxidative stress from exercise is to be consistent. And when it quits being fun, quit. Save
Mm.
it for another day.
Yeah.
And I believe that it's important to run every day, not every other day. Run every day, and just quit when it quits being fun. But you'll find that it suddenly never quits being fun.
Yeah.
And that's why I used to hold the world record for the most 100-mile races run in a year,
Wow.
because it never quit being fun. I used to cross finish lines or come close to finish lines saying, I hope it never ends because of all the adventure and the fun of running 100 miles day and night, things like that.
Yeah.
Uh, but and I would check my inflammatory markers and they would never go up. But if you were a type of runner that types like runs every 2 weeks and then
Mm.
enters a marathon, you'll do well, but you'll end up crossing the finish line, get on your hands and knees, start throwing up. And
Yeah.
then for 2 weeks, you're going to be stiff as a board because of all the inflammation that
Mm.
all these immune cells thinking something's happened to you. They're fighting whatever is there. They don't know what's there, but they're fighting something there. And that's bad for you. That accelerates aging. The number one cause of aging is inflammation.
Mm.
And so you want to reduce inflammation of everything you can. And so I never get that inflammation, okay, because of the fact that when I finish a 100-mile race, go to bed, get up the next day, I can run without any problems at all.
Yeah.
Okay, so and I'm training right now for uh, the world speed record for my age group.
Wow,
And
that's amazing.
yeah, so it's like, but exercise, that's one thing, and it doesn't have to be running. It can be kayaking, it can be bicycling, it can be
Sure.
climbing mountains, it can be all kinds of things. Uh, and then, but there's also so anything you can do to reduce oxidative stress and inflammation. Obesity is a big thing that causes accelerated aging.
Mm.
Uh, Smoking is a big thing that causes accelerated aging, a lot more than obesity and anything else. Uh, but psychological stress accelerates aging. That's why, like, I'm often a keynote speaker at meditation and yoga conferences because I can show data
Yeah.
showing that people that meditate and yoga all the time have biomarkers of aging that are better than people that don't do yoga and meditation. It's so there's a lot of things that we can do. But so in that tug of war that I was talking about, there are ways of reducing the number of people pulling to shorten, and
Mm.
that's by reducing oxidative stress and inflammation.
Yeah.
Most. And
Is there currently a way to measure a person's telomeres or how much telomeres they have in their body?
yes, and I'm the inventor or co-inventor of every one of those methods.
Yeah.
Um, the uh, the ones that really work well are really expensive, not really qualified to be personalized medicine type of things, but they're the kind of research we use here. We use something called TRF, uh, terminal restriction fragment. Uh, that's I think that's the abbreviation. TRF. We've been calling it TRF for 30 years. I forget what the letters stand for now, but that's my favorite method of measuring telomeres because it's like only about $1,000 per sample, and that makes it doable here at my company to do that, study that. But then there's also a procedure that we developed called Telo Smart. It's TELOSMRT, which is where we actually sequence the telomeres and we identify which chromosomes they're on and things like that. That's
Yeah.
I don't want to say a gazillion dollars to do, so we don't do it very often, but it does provide a lot of educational stuff. but people can go get their telomeres like measured. I'm going to say my favorite company is a company called Life Length in Spain that measures the percent of telomeres that are critically short. But I caution people that it's it's very difficult to do, and so it's very difficult to get consistent answers. And so I don't really believe that it's the best way to measure your aging. I actually would recommend DNA methylation is actually a better way to measure your aging, but I do believe that DNA methylation patterns are controlled by the telomere lengths. I mean,
Sure.
telomere lengths are, I think, the main cause of aging, but they're
Mm.
so difficult to measure.
Yeah.
It's hard to get things, but they control other things like DNA methylation and IgG glycosylation. Uh, so measuring those things are probably just as good. But I would recommend doing all of them. And actually, um, uh, True Diagnostic is a company that actually is putting together something that is a combination of everything. Okay, and so I would say uh, if you're focused just on telomeres, go to Life Length. If you're focused on really getting a good measurement of your aging, go to True Diagnostic. And again, I'm not a marketer.
Yeah.
Just I'm not getting
That's great
anything.
information.
Nobody's getting any money for recommending them. I'm just interested in people being happier and healthier, and that's I think those are the best places to go.
Yeah.
Um, but the telomerase activity is a little harder to measure. It's very blood is. I mean, well, first of all, everybody measures things in blood,
Mm.
but your body's a lot more than just your blood,
Yeah.
and blood is very changing all the time. Okay,
Mhm.
cells from your bone marrow are all the time entering your blood, and sometimes bone marrow, all the time, bone marrow cells have much longer telomeres than than every other tissue in your body,
Yeah.
and so sometimes your telomeres get longer, not because they got lengthened,
Yeah.
but because these cells with long telomeres infiltrated your blood, and it's like so there, and also toxins will kill off cells that have short telomeres in your blood. So the analogies I like are if you had a company and you fired your dumbest employees, the average IQ of your company would increase without anybody getting any smarter. Well, the same
Right.
thing is true in your blood. If you kill off cells that have short telomeres, the average length of your telomeres are going to increase without any telomeres getting longer. And
Yeah.
that's not good for you because other cells have to divide to replace those killed cells, which actually means your whole body has shorter telomeres.
Yeah.
On the other side of the coin, the same thing is if you add geniuses to your company, the
Mhm.
average IQ of your company is going to go up without anybody getting smarter. Same with your telomeres. If you add new cells to your blood with longer telomeres, your average telomere is going to increase without any lengthening. And so it's really complicated to try to actually measure. And that's one of the reasons why it's hard to measure aging. But
Yeah.
the Betty White test is really the only thing to do. Um, but the problem is that a lot of a lot of companies are selling products that say they lengthen telomeres
Mm.
without demonstrating that they had induced telomerase activity.
Yeah.
Unlike Telovito does show induction of telomerase activity. But if the other products are toxic at all, they will cause the telomeres to be longer after than before by killing off preferentially cells that have short telomeres.
Yeah.
Same as if the product is immunogenic at all. It'll induce cells from the bone marrow and elsewhere to infiltrate the blood to fight whatever the immune reaction is. So if anybody is looking for ways of lengthening their telomeres and some company tells them, here, look at, we have a product that lengthens your telomeres. Look at people be taking our product, have longer telomeres after they do, longer after they take the product than before. You need to ask them, what does your product induce the expression of telomerase?
Mm.
Because the same thing would happen if their product was toxic or immunogenic, which
Yeah.
is bad for you. And so if they say it doesn't induce telomerase, don't take the product. It's
Yeah.
run away. If they say, then ask why did they even measure telomerase? And they'll say no. And they say, why not? It's easy. It's
Mm,
easy. I know I invented the procedures to do it.
mm,
But I think in a lot of cases they did measure telomerase and didn't see any, and they didn't understand why.
yeah.
But they also didn't understand that their product, if it's toxic or immunogenic, would be explaining the long telomere. So they just assumed that their product did lengthen telomeres, and that's wrong. But I think a lot of people are being misled, not intentionally, but
Yeah.
there's a lot of products out there. It's just audience, even if everything I just said was too complicated for everybody to follow, if somebody tells you they have a product that lengthens your telomeres, ask them, do they have data showing that it induces the expression of telomerase? If they don't have that, the product doesn't work. Okay, so
No. Good to know. That's really great advice. And I'm just curious too, because there's so much stuff out there. Well, there's just a ton of stuff out there anymore, vitamins, nutraceuticals, all sorts of things. It's really hard to know what's good and what's not, for most people who don't, know the questions to ask or things like that. And there's so many new peptides and things out there, the BPC 157s that say that they do cell generation, things like that. What are your thoughts on those things? And, are they safe for people to take? And is it really helping aging?
well, BPC 157 is one of the few peptides that I do really believe in.
Yeah,
Okay, but there's a lot of peptides out there that are just completely fraudulent, and that's because
right.
peptides are easy to
Yeah,
make and sell because it's like it's a way of charlatans to actually take advantage of everybody. Uh,
sure.
so a lot of peptides don't work.
Mm.
I think I mentioned, for instance, I'm one of the inventors of human growth hormone.
Yeah.
Okay, and human growth hormone's really good for you.
Mm.
I mean, it does also accelerate telomere shortening by inducing cell division, and I'll fix that problem later on. But in the meantime, it does make life better. Okay,
Mm.
I
Right.
always say, what's the point of living a long time if you're not living?
Yeah.
HGH is one of those things that can make life better for you. But all the peptides that induce production of HGH, they do not produce anywhere near as much HGH as you can get from injectable HGH.
Sure.
But I mean, it doesn't hurt to take them, except your pocketbook. Uh,
Yeah.
make the marketers a lot of money. But there's yeah. So peptides, supplements, all kinds of things. I do actually have my own podcast
Mm.
that's called Up One.
Okay.
And in that, it's Up One is because what I talk about is critical meta-analysis,
Mm.
trying to blow the whistle on all these products and stuff like that. So instead of just doing so if some company says we have a product that works and here's a peer-reviewed study that proves it,
Hmm.
that's not necessarily proof that it works because it's really easy to get publications to fall through the cracks and get approved
Hmm.
when they don't, when the reviewer should have rejected the publication to begin with. And so what I do, so a lot of people, to get around that, they'll do meta-analysis of peer review studies. Then they'll find some studies that say one thing, some studies that say another thing, and then they'll go with the one that says the most. Well, again, the marketers will make certain that their product is part of that one that gets the most publications.
Yeah.
And so again, it's not believable. So I do what's critical meta-analysis, which means because of my training, everything I learned to try to understand aging, I know, look at their experimental design, I look at their data analysis, I look at how they derived the data, how they interpreted the data,
Mm.
what their conclusions are. I analyze their statistics, their common sense, their logic, all this kind of stuff. And when I do my meta-analysis, I always find that there can be two camps of publications, some that say one thing, some that say the other. But after I do my critical meta-analysis, only one exists afterwards because there's
Yeah.
only one correct answer ever. Okay.
Right.
And so if I still have two answers, then I haven't done enough critical meta-analysis. But so people might want to watch my uh, up one podcast just to find out what's the stuff that really works and what's true and what it's like fact or fantasy, that kind of thing.
Yeah.
Determining that. But Uh, they can find it by Googling up one in my name. But yeah, there's a lot of stuff out there, and because I'm so good at figuring out what's real and what's not real,
Yeah.
all the supplements I take, believe me, I take a lot of them. All of them are the real McCoys. They do work. Uh,
Yeah.
and let me recommend. There's a really good book. Okay, I've become a big fan of a particular doctor that's really just like me, is really good at critical meta-analysis, and has written two books now on supplements and how to choose which supplements. And her name is Dr. Sandra Kaufman,
Okay.
and she's the books are called the Kaufman Protocol. And believe me, when I first heard about this book, and actually I was at a conference and I was walking through the expo where I was actually the keynote speaker. She walks out of her booth and shoves my her book into my bag and says, "Read it." And I walked away, and I because I get so much of that when I go to conferences. Everybody wants me to endorse their products and stuff.
Sure.
But when I was on the airplane flying back home, I saw the book in my bag and I just opened it up. And from the very first page, I was blown away by it. I read the whole book. I've never seen anything written better. It's like a dictionary, instruction manuals on how to choose which supplements you should take. I wrote the best review ever on Amazon.com, and she and I have been colleagues ever since. But I still think the best thing people can do to I really identify which supplements they should be taking is read the Kaufman Protocol.
Okay.
And I want to say the same thing about Touchstone Essentials because I've done my critical meta-analysis of their products, and because they're not focused on profit margins, they're focused on products that really work. They will lose money to get products out there that really work, and they have the best thing. They have products like Gluco Control that
Mm.
converts sugar to fiber. I mean, very few companies have something like this because it's not worth it to them. They don't make enough money selling it.
Yeah.
But it's good. Fiber is good for you. Sugar is bad for you. Zeolites get rid of toxins. They have several. I can't remember the product names, but the ingredients zeolite is in several of their products. Uh, Fulvic acid, the active ingredient in Shilajit. Shilajit is a uh, uh, natural product that people have been using for thousands of years. It is really good, but it also has side effects. Well, the active ingredient of it is fulvic acid, and Touchstone is selling the purified fulvic acid.
Yeah.
And there's a host of products. So I would again, I'm not trying to market, but
That's okay.
I'm telling you what I'm doing. I'm taking the Touchstone products. I'm really sold on it, but I would do that and also follow Sandra Kaufman. And by the way, Sandra Kaufman did write a endorsement for Televital that's put on the website because she believes in it.
Yeah.
And and there's a few other profile doctors in the world that I'm a big fan of because I think they're really honest. They've also written good testimonials profiles on Televital.
That's really great. I mean, just getting good resources, knowing good products to take, what's going to help you and not harm you, that's really great information to have.
Yeah. So I thought we were going to talk about autoimmunity. Uh,
I know we talk about a lot more than that on here, although we do
I
touch
because
on that.
I have a big background in autoimmunity, but maybe we have to save it for another time. I was
Yeah.
I've been involved in inflammation in the immune system, and I understand the balance between like autoreactive immune cells and
Mm.
regulatory T cells and things like that, and induction of immunity and autoimmunity, and something that I would love to come back and do another session on that sometime.
Absolutely. Absolutely. We'd love to have you. I think you're a wealth of knowledge, and I think getting any information we can out to listeners about how to be healthier, live longer, live life better, I think is all really great things. So I would love to have you back to talk about all those things as well.
All
Um,
right, well,
but
good.
I want to thank you so much for being on the show today, for sharing what you're working on, what you've done, all that great information, and then also just doing the work that you've done. I think is really fantastic. The creations that you've made, the work that you've done, just to make such a difference in human life is so amazing. So I want to thank you for that, as well as being on the show.
All right, well, thank you.
All right. And thanks everyone for listening, and we will catch you on the next episode. Bye bye.